Hello friends, welcome to my channel GCS Revision Notes. Today we'll discuss the important formula in the first unit, discrete structures and optimization. So first, propositional logic, A tends to B implies not A or B. A double implies B means A tends to B and B tends to A. So inverse of P tends to Q is not P tends to not Q. Converse of P tends to Q means Q tends to P. Contrapositive of P tends to Q means not Q tends to not P. Now conjunctive null form means with and. So A or B and B or C and C or D. Disjunctive null form means or. So A and B or A and C or C and D. So Boolean algebra laws. So what are Boolean algebra laws? So complement of complement A equal to A. A plus A complement is 1. So the OR form A dot complement A is 0, which is the AND form. Idempotent law. Idempotent law, A plus A equal to A dot A is equal to A. Identity law, A plus 0 is equal to A dot equal to A. Distributive law, A dot B plus C is equal to A dot B plus A dot C. The De Morgan's law, not complement of A plus B is equal to complement of A into complement of B. Complement of A dot B is complement of A plus complement of B. Dominance law, A plus 1 equal to 1, A dot 0 equal to 0. Absorption law, A dot A plus B equal to A plus A dot B equal to A plus A complement dot B equal to A plus B, and A dot A complement plus B is equal to A dot B. Commutative law, that is A plus B equals B plus A or A dot B equal to P dot A. Associative law with three variables, that is A plus B plus C is equal to A plus B plus C. A dot B dot C is equal to A dot B dot C. Next, XOR A XOR B means A B bar plus B A bar. XOR A dot B means A B plus A bar B bar. Then canonical forms, the sum of minterms or sum of maxterms means sum of the sum of products. Okay, it is represented by sigma. If it is part of max terms, it means this product of sums represented by pi. Now sets and relations properties. Associative means A plus B plus C is A plus B plus C. Commutative means A plus B equal to B plus A. Identity element is A star E equal to E star A, where E is the identity element. So inverse element means X into X inverse will be equal to E. So distributive law, here X star Y plus Z equal to X star Y plus X star Z. So you can say that star is distributive. Star is distributive over plus. So only star is distributive over plus. De Morgan's law, A union B complement is A complement intersection B complement, and A intersection B complement is A complement union B complement. So what are the relations? So reflexive relations, A relation A means that is whole. That is, if it's A relation A holds. So if it's A, then other A should be there for reflexive. Irreflexive means A relation A does not hold. Symmetric, X relation Y means Y relation X. It is symmetric. Asymmetric, asymmetric means A relation B holds means then B relation A does not hold. And also asymmetric, A and B does not hold. For antisymmetric, so A relation B holds means then B relation A does not hold, and B will hold. This is the difference between asymmetric and antisymmetric. Next, transitivity. So what is transitivity? X relation Y and Y relation Z implies X relation Z. So equivalence relation. So equivalence relation means it is combination of reflexive, symmetric and transitive. So short form related as RST. So reflexive, symmetric and transitive. Next, partial order set or poset. So you can remember as RAT, that is reflexive, antisymmetric and transitive. The properties of sets, that is n of A union B is equal to n of A plus n of B minus n of A intersection B, and n of A union B can also be written as n of A minus B plus n of B minus A plus n of A intersection B. Okay, next n of A is n of A minus B plus n of A intersection B, or n of B is n of B minus A plus n of A intersection B. So permutation combination, So permutation means all possibilities. So the formula is NPR is equal to n factorial by n minus r factorial. Okay, so there are many formulas for permutations. So number of permutations of n distinct objects taken r at a time is n factorial. Okay, and some of the formulas are given here. Okay, next combination. So what is combination? Combination means required possibility. Means you select the combinations. So NCR is equal to n factorial by n minus r factorial into r factorial. So inclusion exclusion principle. A union B is A plus B minus A intersection B, and A union B union C means A plus B plus C plus A intersection B intersection C minus A intersection B minus A intersection C minus B intersection C. So important formulas from the graph theory. So simple graph, the degree V will be less than or equal to n minus 1, where n is the total number of vertices, and number of edges will be NC2, that is n into n minus 1 by 2. The number of simple graphs that can be drawn with n vertices is 2 to the power of NC2. That means 2 to the power of n into n minus 1 by 2. The complete graph number of edges will be n into n minus 1 by 2. Degree of any vertex will be n minus 1. So handshaking lemma or sum of degree theorem. So here sigma, the degree of the vertices, that is sum of all the degree of vertices, is equal to twice the number of edges. So 2 d of v is 2 times e. So sum of degree of all vertices is twice the number of edges. So you can say that sum of the degree of all vertices is always even, and sum of degree of all vertices is even. The number of vertices of odd degree is always even. C3 is a cycle graph. It is also called as wheel graph. So you can find the difference between the Euler's graph and Hamiltonian graph. So Euler's graph means what? Edges are not repeated and all vertices are of even degree. It will not be an Euler circuit if it has exactly 2 vertices of odd degree. In case of Hamiltonian graph, here vertices will not be repeated. It will not be an Hamiltonian graph. It will not be an Hamiltonian circuit if it has one vertex of odd degree. It has one vertex of odd degree. So first we'll see the Dirac's theorem. Dirac's theorem in a connected graph with n vertices. If n greater than or equal to 3, d of v is greater than or equal to n by 2, then it is an Hamiltonian graph. Case of Ohm's theorem, here in a connected graph with n vertices, here n will be greater than or equal to 2. So d of u plus d of v will be greater than or equal to n, where u be are non-adjacent vertices. Then it is an Hamiltonian graph. A simple graph with n greater than 2, the number of different Hamiltonian cycles is n minus 1 factorial by 2. Trees with n vertices has n minus 1 edges. At least 2 vertices will have odd degree. Will have a degree of 1. Spanning tree. It is a tree with n vertices and n minus 1 edges. It is a subgraph of G and it has all the vertices of G. Planar graph. It is a graph with no intersecting edges. So in a planar graph, the number of regions are in a graph, in a connected planar graph with E edges and V vertices is R is equal to E minus V plus K plus 1. So E number of edges, V number of vertices, K is the number of connected components. So for a connected graph, K is equal to 1. Next we have another formula. If V vertex greater than or equal to 3, 3V minus C also holds in case of planar graph. 3V minus C greater than or equal to 6. Cauchy's theorem, a graph is planar if there are no subdivisions K5 or K33. So K5 and K33 are minimum non-planar graphs. Graph coloring. If the number of vertices in a cycle graph is even, then chromatic number is equal to 2. If the number of vertices in a cycle graph is odd, means the chromatic number is equal to 3. What is four-color theorem? Chromatic number of any planar graph is not greater than 4. Chromatic number of a bipartite graph is always 2. K4 is a complete planar graph. For a complete graph Kn, different spanning trees possible is n to the power of n minus 2. So a complete graph Kn, different spanning trees possible is n to the power of n minus 2. For a bipartite graph, KMN, difference parity is possible is m to the power of n minus 1 into n to the power of m minus 1. And some of the important mathematical formulas, the sum of n natural numbers is n into n plus 1 by 2. Sum of n terms in AP is n by 2, 2a plus n minus 1 into d. When is the last term, a is the first term and d is the common difference. And we determine the nth term in an AP, the n is a1 plus n minus 1 into d. Sum of series 1 square plus 2 square plus n square will be n into n plus 1 into 2n plus 1 by 6. And the sum of series 1 cube plus 2 cube up to n cube will be Sn is n into n plus 1 by 2 the whole square. So friends, please do like, share and subscribe my channel. If you want any notes for paper 1 or paper 2 and discrete structures, please write in the comment section. I shall help you. Thank you.